In this video, we want to model this architectural form in several different ways. Then we'll compare to see which technique is faster, more accurate, or more suitable, and whether there is any noticeable difference between the methods or not. So stay with me until the end. Hi, I'm Hossein. Welcome to my channel. In this video, we're going to explore modeling an architectural piece using several different methods. If you watched the last episode of the Rhino for Absolute Beginners series, we did something similar there. Here, we'll continue on the same path and model different forms from a comparative perspective, so you can deepen and make your modeling experience more practical. If you enjoy this type of content and haven't subscribed yet, hit that subscribe button and ring the bell so you won't miss the upcoming videos. We've got more tutorials on the way, and if you feel like you need a more basic introduction, I have a 4-part crash course called Rhino for Absolute Beginners right here on this channel. I'll drop the playlist link in the description. I highly recommend checking it out. All right, let's get started. Simplify the form in your mind. Let's go back to the rule we set in the Rhino for Absolute Beginners course. When you face a new model, don't panic. Often forms look complicated at first glance, but if you just take a few seconds to observe and analyze them, you'll realize they're much simpler than they seem. So the first step in modeling is to simplify the form in your mind. Look at what components make it up, what elements it has, and how everything connects. For example, when I look at this model, the first thing that comes to mind is that it's made of 2 main parts: an internal ramp, an outer shell or structural frame. In this video, we'll model each part using different methods and then review the results together. To start modeling, I first draw a circle with a radius of 15. Then, using the divide command, I split it into 20 segments to get 20 evenly spaced points along the circle's perimeter. Next, I select both the circle and the points and make a copy with Ctrl+C / Ctrl+V, moving it 60 units upward. All right, now it's time to move on to creating the ramp inside the structure. Creating the ramp. To build the ramp, I use the helix command, and as you can see in the image, I draw the spiral path on the base circle. Since we set the total height to 60 units, I set turns to 12, so that the floor-to-floor distance is roughly 5 units. Of course, you can adjust this number depending on your needs. Next, using the offset command, I create a parallel curve at the desired distance. Here I'm using 3 units to define the ramp's width. Finally, with the loft command, I turn these 2 curves into a single surface. Modeling the outer structure, we'll model the exterior wall using 3 different methods. Method 1. As shown in the image, I start by creating the first element using the points we generated earlier with the divide command. Make sure OS snap point is on, so you can easily select the points. Next, using arraypolar with the center of the base circle, I replicate this element 20 times to form the perimeter grid. Now let's shape the form. I run the cageedit command and select the entire form. Following what we learned in the beginner course, I set the cageedit options and adjust the control points to X bar 2, Y 2, Z bar 5. Then, as you can see in the image, I select the middle control points along the Z-axis and pull them inward slightly to create the main curvature of the form. Next, we move on to the details. Using pipe, I turn the perimeter elements into pipes and set the desired thickness. I also thicken the ramp surface using extrude surface by about 0.1 units. Finally, I add details like the ramp railing following the reference image. Naturally, the more time you spend on this part, the cleaner and more precise your output will be. Alright, let's move on to method 2. In this method, when you draw the first element and want to use array, design its shape a little wider, as you can see in the image. Then, just like in the previous method, use arraypolar with the circle's center to replicate this element 20 times. The wider shape means we don't need cageedit for the outer structure itself. However, the ramp we built earlier now extends beyond the outer shell, so we need to adjust the ramp using cageedit to align it with the exterior curve. This is exactly the same process I went through in method 1, so I won't go over it again here. We'll keep things concise. To wrap things up, we handle the remaining details just like before, convert the columns to pipes using pipe, thinken the ramp surface with extrude surface, add the rest of the details, and that's it. With these steps, the model is complete and ready. Here's a quick look at Grasshopper. Actually, if we wanted, we could build this entire form completely parametrically in Grasshopper. I'm currently working on a full, detailed Grasshopper tutorial for this channel, so if you're interested, make sure to subscribe so you won't miss it when it's released. Alright, let's move on to the next method. Method 3. In this method, instead of creating a full element like before, we start by drawing a simple vertical line. Then, using arraypolar, we replicate this line 20 times. Next, with the twist command, we twist the lines to form the initial shape of the structure. After that, we mirror the angled lines around the circle's center to complete the full structure. Finally, we refine the form using cageedit to get the curvature you see in the image. As I went through in the previous methods, I won't repeat all the steps here to keep things concise. Then, just like before, convert the columns to pipes using pipe, thinken the ramp with extrude surface, model the remaining details, and that's it. With these steps, the model is complete. What you saw today were several different ways to model an architectural form. Some methods are more complex but precise, while others are faster but less accurate. The truth is, there's no single right way. The right method is the one you're comfortable with, and that helps you achieve the result you want. With practice and experience, you'll gradually reach that point. Sometimes speed is important, and you want to model your idea quickly, and other times, final accuracy matters more and requires extra time. In the image you see, you can compare the quality differences of all three methods. For example, the curves of the outer grid in method 3 are noticeably different from the other two. Thanks for joining me in this video. In this series, I'll continue to show you more different modeling techniques. Don't forget, if you enjoyed the video, like, subscribe, and share it with your friends so they can benefit too. Also, leave your thoughts in the comments so I can prepare even better tutorials for you. See you in the next video. Take care.